All right, let's get into it. Today, we're going back to square one to really understand the true nature of data. We're going to look past the stuff we're all used to and get our hands dirty with the raw material that fuels everything we do.
So if you've spent any time at all with databases, you probably think of data as these nice, neat tables, right? Everything fitting perfectly into rows and columns. But is that really the whole picture? Oh, not even close. We're about to blow that idea wide open.
So, first up, let's talk about what lies beyond those comfortable rows and columns. We're expanding our definition of what data even is.
Let's just ask a really basic question. You work with it every day, but have you ever stopped to think, what is data, really? The answer has changed a lot, and getting a grip on all its different forms is absolutely the first step to mastering analysis today. Okay, so at the very heart of this is one key distinction. You've got your numerical data, the stuff in spreadsheets. Think of it as a representation of the world, right? It's a number that stands in for something, like a person's weight. But then you have things like text and image data, and these are completely different. They aren't just representations, they are the actual objects of study themselves. We're analyzing the words, the pixels, the thing itself. And because of that fundamental difference, you get a whole new set of challenges. With text, for example, just think about two huge ones, search and matching. Consider the entire World Wide Web. Just finding what you're looking for in that massive ocean of unstructured text is a mind-boggling problem. It's a challenge that just doesn't exist in the same way when you're dealing with clean numerical tables.
Okay, so now that we're thinking bigger than just numbers, we've got to face a universal truth that every single one of us knows in our bones, the reality of messy data.
So why is that? Why is it that real-world data is almost never clean? It's a question that's probably driven you crazy at some point. You get a new data set, you're excited, and then it's a disaster. Is that an exception, or is it actually the rule?
Well, check this out. This quote completely flips the script. It says that if you get raw data that doesn't have problems, that's when you should be suspicious. So if you get a data set and it looks perfect, your first reaction shouldn't be, great. It should be, what did somebody do to this before I got it?
This means you should just go in expecting these problems. Things like missing values, weird distortions, simple typos and misrecordings, or data from a sample that wasn't chosen well, these aren't failures. They are inherent features of collecting data from the real world. Right from the start, these are the things you should be hunting for.
All right, let's tackle a concept now that's a little more complex, but it is absolutely crucial for understanding modern data. We're going to talk about something called the curse of dimensionality.
We're all used to thinking of big data as being very long, millions or billions of rows. But what happens when a dataset gets really wide, meaning it has a huge number of variables or columns for every single record? Well, this is where our human intuition starts to break down in some really, really strange ways.
So what is this curse? In simple terms, as you add more and more variables, more dimensions to your data, the amount of data you need to actually understand that space goes up exponentially. Your data set gets spread incredibly thin to the point where it's mostly empty space. And this has some very counterintuitive effects.
So here's the first mind-bending effect. In a high-dimensional space, almost all of the volume is near the surface. This means that pretty much all of your data points, even if they're spread out evenly, are going to be clustered in a thin shell right around the edge. The center of your data space, it's basically empty, a ghost town.
And here's the second weird consequence. In that high-dimensional space, the whole concept of nearby just kind of loses its meaning. The distance to any point's nearest neighbor becomes, on average, huge. Everybody is far away from everybody else, which, as you can imagine, creates massive problems for any algorithm that relies on the idea of proximity or clustering.
So, we've talked about messy data, the curse of dimensionality, and it can all sound a bit discouraging, I know. But I want to end this by reframing these challenges. They aren't just problems, they're part of the actual adventure of data analysis.
I love this quote because it puts it so perfectly. The idea that you can just apply one technique and get a perfect answer is a myth. Real data analysis is iterative. You probe the data, you look at it from another angle, you transform it, and you start again. It's an investigation. It's a voyage of discovery.
And that's really the big takeaway. This whole thing calls for a change in mindset. Data analysis is not about following a recipe in a cookbook. It's a journey, an exploration, where you're the investigator uncovering the hidden secrets within the data. And frankly, that's what makes it so exciting.
If you found this useful, please go ahead and hit that like button.
share it with someone who might find it interesting, and subscribe for more deep dives just like this one.
And I'll leave you with one final thought to chew on. We've just established that raw data is inherently messy, that clean data is a myth. So what are the real implications of that for all the automated systems, from credit scoring to medical diagnostics, that are being built on top of this imperfect foundation? It's a big question and one worth thinking about. Thanks for watching.